Hello there, I'm Thomas Hatsios, the pilot, captain flying the Boeing 777-300 ERX in tonight's flight, so thank you very much for joining me. This is a Boeing 777-300 ERX aircraft of the PMCG simulation. It's a Flight Simulator X. So right now I'm in the cockpit of the Boeing 777-300 ERX airplane. I'm going to show you the instruments inside the cockpit and explain some of their function. I'm also going to make an engine start demonstration before takeoff and flight, and also show you that process. I'm going to set up a flight plan, flight path for the aircraft to fly. So I'm going to show you the primary flight display with the flight mode annunciator. The primary flight display contains information like the airspeed of the aircraft, the barometric altitude above the sea level, the barometric pressure of the atmosphere around the aircraft, the magnetic and tube heading, the flight guidance of the flight director with the pixel under and the pan goggle in the crease, and also the flight director crossbars. We also have the airspeed selected and the altitude selected from the autopilot of flight director system panel. We have also the vertical rate of climb and descent in thousands of feet per minute or hundreds or tens of feet per minute. We also have the flight mode annunciator with the auto throttle and the autopilot lateral and vertical navigation modes, and also the Lszh localizer approach mode. So you can see these things here. We have the primary flight display, as I told you. We have the airspeed selected over here, displayed with magenta. The altitude selected, the barometric altitude above the sea level, the airspeed, the radio altitude, the flight director crossbars here with the Lszh localizer also, and the magnetic tube heading, the magnetic pressure, and the flight mode annunciator, the FMA. That displays the autopilot and auto throttle modes here that we select, and also the Lszh localizer. So we also have the navigation display that contains the airports, the waypoints, the board, the ADS, the position of the aircraft, our own aircraft position. We have information like the terrain level, reflections from the radar of the terrain and the weather, wind shear, other information like other aircraft will fly around us, using transmission of our ADS-B and ADS-C transponders that transmit the position and the altitude of our own aircraft and receive the position and the altitude of other aircraft flying around us. So you can see this here. We have also the waypoints, the navigate, the ADS, the board. We also have the horizontal situation of the aircraft in terms of the flight plan. We're gonna input using the flight management computer here. The FMC CDU, this and this, the flight management computer. We have three control display units for this. So we're gonna create a flight plan. The aircraft is gonna fly into. We're gonna see it later. So we have the terrain here, green, red, and yellow. You can see the terrain level, maximum 6,700 feet, minimum 0, and traffic. We have some other aircraft around us. You can see airports. The distance here right now is 320 nautical miles. We have the track, magnetic, and true. The ground speed. So there is a difference between the magnetic north pole. There is a difference between the magnetic north pole and the true north pole. The magnetic variation. So we display that in the primary phone display the navigation display using the ADIRU, the Air Data Inertial Reference Unit. We have the ADIRU over here in the overhead panel. As you can see, this is the ADIRU. We use this switch here. I'm gonna send you this view. So what is this switch the ADIRU is doing is it contains some systems and manages this system. It's a kind of computer. So it's the data inertial reference unit. It contains 2 GPS or 3 GPS. It contains barometric and anemometric data of the aircraft using the pitot static and pitot dynamic tubes, and also contains a magnetic compass and other systems like gyroscopic acceleration and deceleration using laser gyros. And display this information here and here. We need to align sometimes this IRS, the ADIRU, Data Inertial Reference Unit, has different names in different aircraft models. So you can see the autopilot section here. You can see the airspeed selected, the heading selected, the vertical speed and the altitude selected, the autopilot engaged, the autopilot disengaged here. So we have also the ACAS, the upper ACAS and the lower ACAS, and the information that contains. So here's the overhead panel. You can see also other systems like the left and the right integrated drive generator, the electrical system. This is the primary flight computers of the aircraft, the flight control computers, the ADIRU that I told you. For the Air Data Inertial Reference Unit, GPS, gyroscopic acceleration, deceleration. All this information is displayed here and here. Primary flight display, navigation display also feeds this information to the flight management computer here, and other systems like the FADEX of the engines and the autopilot and the autocraft. So we have a few more minutes left for this flight. I'm gonna show you also this view now, the virtual cockpit, this view. So I will show you other systems also. I told you we have the ACAS, the upper ACAS and the lower ACAS. We have the autopilot and flight director system panels. So you have the airspeed selected, the knob, airspeed select knob, the airspeed select modes like the climb and the flight level change. We also have the laser navigation, the vertical navigation of the autopilot and auto systems. that are being created using the flight management computers that I show you. That we input all the data of the aircraft like its gross weight and fuel, the plant fuel for flight and the reserve fuel, the cruising altitude, other things like the temperature, the barometric pressure. So takes all this information like the departure runways, departure airport, arrival runway, arrival airport, and the intermediate waypoints and fixes we're gonna fly through, and it manages all the navigation stations like the VOR, ADS frequencies. It tunes all the frequencies that the aircraft needs to be tuned in the radio management panel, like the ILS also, the ILS localizer, which is very important for ILS localizer approach. This is tuned by the flight management computer when we select an arrival runway with an ILS. It's tuned automatically when we are closer to the airport, like in the long final. So I'm gonna show you now the autopilot. I told you about the airspeed select. We have the autopilot engage and investigate, the autothrottle engage and investigate, the airspeed select, the lateral navigation, vertical navigation, the heading select node, the final angle select node. We have the heading hold switch. We have the vertical speed for the rate of climb and descent of the aircraft using the autopilot vertical rate of climb and descent modes, and also the altitude hold. And we have the approach localizer mode and the approach localizer, and the board lock switch, and also the approach localizer switch, the flight director switch, the auto throttle connect and disconnect, the autopilot connect and disconnect. We have also the FS panel with all flight instrument system. So this is the autopilot here panel that we use. You can see we have the switches here. We can change the airspeed. For the takeoff, we can select the runway heading here, which is more correct. So we can, this is the pressable, the switches, select a mode. You can also change the bank angle limit here when flying with the autopilot on. You can select the hold switch here. If you select this flight level change, this is for takeoff, this airspeed, so you can select also the altitude here. To the thousands, so we'll select the flying altitude, cruise altitude, and the pressure switch when flying. So you select this mode. Have also the LNAV, the VNAV. So we also got, if we select this hold mode, is gonna change from the flight level change. So we also have the vertical speed flight path angle that also selects another mode, so we can descend or climb minus 2,500 feet or climb plus 2.5 or 3,000 feet per minute. This aircraft will select whatever vertical speed we need. So you can see this the VS here, engage the heading hold, engage. So now if we change to the flight path angle, we have flight path angle FPA. It's gonna display FPA here, heading hold in FPA. Another mode you can select to climb and descend the aircraft in degrees. So you can descend like 3 degrees, 3.5 degrees, or climb like if you move this slider up and down over here. So you will see the vertical speed in degrees here for climb, FPA, flight path angle. We have the radio altitude here. I told you, primary flight display, flight mode announcer here, navigation display, upper ACAS and lower ACAS. So We have about an hour left for this, so we are in good timing. You can see other things over here, the overhead panel. I told you about the ACAS. Here is the engine indication through alert system, the upper ACAS. So you can see this is the N1. The N1 is the low speed, low pressure compressor state of the engine. So I will show you now the ACAS, the upper ACAS and the lower ACAS. The ACAS contains information permanently like the engine indications, the N1, the low speed, low pressure compressor states of the engine, the exhaust gas temperature, the flap setting, also the outflow valves position for the cabin pressurization, and the inlet pressurized air from the left and the right engine for cabin pressurization, and it's used also for air conditioning and for hydraulic fluid pressurization. This is the duct pressure from the 5th and the 9th stage of the turbofan engine, and also for hydraulic fluid pressurization when an engine at the ice. And we also have the lower ACAS here. This is the upper ACAS that contains all this information. This is duct pressure, the cabin altitude, the rate, and the N1 low pressure, low speed compression stage of the engine, the exhaust gas temperature, left and right engine, the flap setting, the landing gear down and up, some warnings with yellow, and the total fuel in thousands of the total fuel inside all the fuel tanks, left and right wing, center tank, and also the temperature of the fuel. So you can see also in the lower ACAS we have the Enduro, which is the high pressure, high speed rotor stage of the turbofan turbocharged engine. We have the fuel flow per engine per hour, the oil temperature, the oil quantity, the vibration of the engine. So you can see the oil pressure, oil temperature, fuel flow per engine per hour, 1000 kilograms, 1000 kilograms per engine per hour right now, the idle. The N2, which is 69.9%, the oil temperature, oil quantity, and vibration, left and right engine. So you can see here we have the thrust levers. This is the autopilot I was telling you. So this is the landing gear extend and retract lever. We have the alternate here. I think this is gravity extend, the alternate. So we have flap override, gear override, current speed, the auto brakes here. You can use the auto brakes. So you can see here we have many switches. In the overhead panel also we have the electrical left and right engine electrical system. So we have like an hour left for this flight, trying to be more brief. So we're gonna make an engine start demonstration in a while. I'm gonna show you now the flight controls, maybe using the flight control column and control wheel and also the side stick that I use. So we use a yoke for the Boeing aircraft or a side stick, whatever you like. It has the same function used in later. So you can see I can pitch up and pitch down the control yoke here. I can also barrel roll left and right. This is the flight controls for, I'm gonna show you now. So this is the display, synoptics, flight control. Here you see here we have the flight controls of the Boeing. You can see the left ailerons, right ailerons here, the stabilizer trim, the rudder trim. Flight controls mode is normal. So it's for the Boeing 777. This is the engine to the right wing, the horizontal tail stabilizer, and the elevator position, and the stabilizer trim, and also the rudder, the vertical tail here. But you use the rudder pedals to move the rudder around left and right. So using the rudder pedals, you move the rudder, as you can see. So you have full function with it. Electrical. So the flight controls, I will keep showing you that for a couple of minutes. So You can see I'm using this side stick here for this simulator. The Logitech Stream 3D, as you can see. So you can pitch up and pitch down the aircraft. You can bang roll left and right, and also use the rudder pedals, the stabilizer trim, position, the flap settings, and also the thrust levers. So you can see there is proportionality between moving up and down on the side stick and also moving around on the control yoke and the control wheel. It's a very nice proportionality for the simulation. So when you pitch up the elevator, you pitch up the nose. When you pitch down the elevator, you pitch down the nose. So you deflect the surface, the flight control surface up and down. That creates an aerodynamic force, a differential pressure in the flight controls that you see here and also outside. Here, this is the elevator position, up and down. That makes the aircraft to create an aerodynamic force in the tail to pitch up and pitch down the aircraft nose around each center of gravity and center of pressure that is located. So the center of gravity and the center of pressure of the aircraft is located approximately 35% of the mean aerodynamic chord of the forward wing position. And this makes the lever arm between the forward wing center of pressure and center of gravity to rotate the aircraft using the vertical force, the moment arm, or if you want it using the Newton's physics, it creates can create also a centrifugal force. So it's pretty much the same like the moment arm. So this makes the aircraft pitch up and pitch down like this. So you need the aerodynamic force in the forward wings. You have this aerodynamic force in the forward wings only when you have effective flight controls and effective airspeed. Your airspeed is high enough using the thrust from the engine, the thrust levers, to move the aircraft forward, like 200 knots for this aircraft, 300 knots and higher, 200, maybe 50 knots is like a minimum using flaps. So if you have higher speed than 150, you can fly the aircraft normally. Using some flaps above 200 knots, you can retract the flap. 250 knots you fly flapless. So you have the same effective aerodynamic controls, having the same effective airspeed and aerodynamic lift. So you use the aerodynamic pressure and lift in the forward wings principle from the flight dynamics and the Newton's physics and some aerodynamics to make a theory about the aircraft flying. So you also use when you use the bang roll left and right, it creates differential pressure between the left and the right wing that makes the aircraft turn around its center of gravity again, and having a kind of centrifugal force. So there is less lift in one wing than the other. So it makes the aircraft have a G-force load more in one wing, more G-force load in one wing than the other as it flies. So it makes the aircraft to advance the one wing forward. So this makes the aircraft bang roll, or you can do the same with the yaw using the vertical stabilizer of the rudder. You do it with the rudder pedal. So you can see the rudder here, the elevator. So we have all the flight controls of this aircraft for the Boeing 777. It's pretty much the same for every aircraft, airliner or fighter jet. So We also have other flight controls like the flaps and the slats that create additional lift. So I'm gonna show you now some systems. So this is so much for the flight control system. I hope you like it. Hope you find it interesting. I'm gonna talk to you now about some of the systems inside. Then make an engine start demonstration. We'll fly a little bit. We have about 50 minutes left for this flight. So we have the overhead panel here. I have to come here in this view. So I'm gonna show you. We have the modes. We have the engines here. We have the status. So you can see the status. We have the hydraulic here. Permanent tank. The APU. The oxygen. If I come in this view, some coffee. We need to start this VAPU switch here. We can use this view also. Or we had upper bar. So we have this nice view here. We need this is the auxiliary power unit. It's gonna start the engines in the ground. Make an engine start. We need this. When we start this, we can turn off the alternate current degree drive generators. We have one installed per engine, 115 volts, 400 Hz frequency is the electrical symbol here. So 115 volts from the left engine, 150 volts from the right engine, 400 Hz frequency. So if you come here, you will see the electrical. 115 volts, 150 volts, 400 Hz frequency alternated from the IDC drive. You see the drive here, which is permanently connected using an electromagnetic brushless alternator that is connected hydromechanically using gears in the shaft of the turbo jet or turbofan engine. So we have 115 volts or 200 volts higher, 400 Hz, 120,000 volts or 120,000 kilovolts, each one 240,000 kilovolts total or 240,000 watts. So we have the APU now running. So it's 120,000 watts from its IDG, electrical alternate current, which can be converted directly using the transformer rectifiers. We also have the main battery. You can see here the system. 37 volts main battery and DT battery. It can be converted using static converters in direct current. You also have the backup generators, 35,000 kilovolts each one, 115 volts, 400 Hz frequency alternate current. So we now have the APU. We have other systems. You can see the doors here are closed, so the cabin can be pressurized. We have the landing gear. You can see the temperature of the brakes and the pressure from the tires. So the electrical, the hydraulics. You can see the left and right engine hydraulic systems here. If I come again in the overhead panel, now we have the APU here running. Where you can see. We have a few more minutes, so we can disconnect if we want this integrated drive generator, just to show you a display of what happened. So we're gonna lose some systems, not everything. Electric generator right off, and electric generator left off. You can see the message here, it's a full message. We can reconnect that. We can turn off the hydraulics here in the off position. This is hydraulic pumps, left and right engine, hydraulic fluid pumps that pressurize the hydraulic fluid. We have the ADIO, the flight control computers, also in more systems. We have the fuel tanks here, fuel pumps also, and fuel valves. So this is the hydraulic. You don't see the full message now, it's coming on. It's generated from the computers, so we have hydraulic system, left, center, and right. Flaps, primary fails, light control, flaps, primary, auto brake, auto light. So many systems that use the hydraulic fluid, and they are in fault right now because we have no hydraulic pumps from the engine. We turn them on. So you can see here we have no left and right, and also we have no flight control now. You can see there are cross and yellow. You can see the left LCR, left, center, and right. All systems and the engine driver and the backup. So this has no effect now in flight control. Only see this warning. So you can see the flaps, hydraulic pressure system left and right, the stabilizer trim that I was telling you that stabilizes the aircraft in flight, the horizontal tail. So we go back to electrical normal hydraulic. Here we have some fault. You can see it's wide, so there is no pressure. It's only 50 psi right now. It should be 3000 each one. You can see the flaps, the flight controls like the ailerons, spoilers. Also supplies many systems. So in the upper panel you can see again here we go into the hydraulic fluid pumps here and turn them on. All the generators on. If we have time we're gonna show more systems. So we have also the RDIs, we have the lighting here, we have some wipers here for the window wipers. We have the passenger oxygen in the window heat, so you can turn on the crossfit valves here for the fuel tank. We have also the fuel jettison. You get dump fuel here by arming this switch or disarming it. So we have electronic engine control computers for the left and right engine, the auto start here. You can start the engine like that. You can turn on and off. This system is back to the normal. So these two controls, the FADEX, the full authority, the engine control computers. So we have also the cabin pressurization here, forward and aft, the outflow valves. Now we can use these controllers to pressurize or depressurize the cabin of the aircraft as we climb or as we descend by opening and closing the outflow valves. And also select the landing altitude. If we use the auto recovery, you need to do nothing about that. So we have here also the air system, the left and the right engine. This is the left, right engine. This is the APU compressed air. This is isolation valves. We use this to isolate an engine bleed. I'm gonna talk to you about later. This is the PAX bleed that supplies with compressed air from the engines and the APU. The cabin pressurization system, the wing and engine RDIs here. You see the other need to pressurize hot air for this. And also the hydraulic fluid tank. So this is so much for the Boeing 777 system. I believe I'm gonna show you a couple more things. In the display we have like 30 minutes to go. So I'll come in here. You can see we have the virtual cockpit now. The hydraulic is normal. I'm gonna show you also this view. So you can see the hydraulic, the primary and the backup. This is the engine driving. You can see the left electric, right electric, the air system, the electric C1, C2, the primary, the left engine here. This is the system. The right engine, the pressure 3000 psi of hydraulic fluid using for all these systems. Like the flight controls, the rudder, the elevator. So we have also the fuel pumps here. Left and right wing fuel and the toggle fuel, the left and the right engine symbol, the low and high pressure fuel valves, the APU. So you can see the forward and the aft valves, the DC here, electric for the supply of the APU. In case we need to start the engine, we have only DC electric. Also here we have the air system also. Left and right engine, the compressed air for the engine starter using the APU. We're gonna see this later, automatic. And we have the outflow, the engine bleed for, this is the trim air for the PAX. for the cabin pressurization, for wing and engine RPIs, as I said, and the flight controls hydraulic fluid. You can see here the flight controls and the wings of the aircraft to make the aircraft fly. So we have other modes. We have the engine again. We have some checklists here. We have the normal checklist, like before takeoff, what we need to do before start. We have many items. I'm gonna show you also the fault layer, the fault items. So you can see the checklist is complete here. Checklist is complete. We have the non-normal menu. We have an engine flight control, engines, and APU. Here we select this item. So damage, fail, shut down, thrust. So let's say engine failed right. We will lose the right engine. What we need to do is thrust loss on both engines? No. You can see here the items, objective to restart the engine if needed. Condition engine speed is below idle. So we go lower to that, restart is needed, yes. Monitor adjust gas temperature, engine may accelerate to idle. So this is the item 2. We continue. Airspeed is or above, let's say it's above slow acceleration. So also this. So these are all the items we need to do to restart the engine in the air if we have an engine failure. Both engines run normally. Plan to land at the nearest airport. Landing using flaps 20, yes. Let's do this faster. So these are all the items. So here we have the normal. We have also the communications here, the traffic control. This is for the checklist, the engines. So we're going to this view now again. So you can see here we have the communication, radio communication panel, the stabilizer trim position, the stabilizer trim normal and alternate. We also use this switch here for stabilizer trim, picks up and picks down, and also free autopilot disconnect here. The aileron trim here, the rudder trim here, the fire extinguishers here, the fuel set-off levers, and also the stabilizer trim left and C and right. You should leave this in the normal, not disconnect this. We have the speed brake here. We have the flap lever here. You can see the flaps position. We'll use the flaps for takeoff. So if I'm gonna move the thrust levers forward, you're gonna see the thrust is increasing. The N1, which is the high speed, high pressure compressor stage of the engine, the exhaust gas temperature, some messages here, fuel pump center, we have no fuel here. So this is the flap setting, see the outflow valve, the duct pressure. So this is normal, the engine is indications, the N2, which is the high speed, high pressure compressor stage, the fuel flow 5000 kilograms per hour, oil pressure, oil temperature, oil quality, and vibration of the engine. So if I move this back, I can disconnect the auto throttle like this. I can use this for takeoff, go around, and also I can use this, move this handlebar to slow down the aircraft. To use the reverse thrust in the ground. So you can see the reverse with green here. This is the message. So you can see the blocker door here is open, and we have reverse thrust on the engine. Slow down the aircraft after landing. So we need to make the restart now of the engine very quickly. We did all the items before engine start. So we take the thrust levers back to the idle. Here we also have the transporter. I'm gonna talk to you later. Here we have the TCAS system, also the traffic collision alert system. The communication panel for the radios and navigation panel, also the radar here, the weather and terrain radar. So I'm gonna turn off both engine fuel cut-off levers to the idle, to the shut-off position. I'm gonna turn off both engines because we have the APU on now. So you can see the reconfiguration here in the overhead panels. We have like maybe 30 more minutes to go for this flight. So you can see the N1, the exhaust gas temperature, the slowing down, the N2, the fuel flow, oil pressure here, oil temperature, oil quantity and vibration in the engine. So if I come up here, this is this airplane, the Boeing 777. You can see the engines are going down to the idle, both of them, because there is no fuel. This is the left engine is to the idle, slowing down. So we only need to see this. The N2 now is 0, almost. The fuel flow is 0. The N1 is 0.1, it's very low. The N2 is 4.2, it's going down. So we're gonna restart the left and the right engine. First, the left engine first. Here is the engine starter for the auto start system. So you're gonna see many reconfigurations here. So you're gonna see the engine shutdown. Here's methods, and also the N1 increase, the exhaust gas temperature. The N2 increase above 20%. The fuel flow. This is what we do now. We take compressed air from the APU, the auxiliary power unit, that we use to supply with compressed air this aircraft for starting the engine. You can see the spinning of the engine increase. So we can let the fuel now into the left engine. We have enough compressed air into the engine starter. So you're gonna see the fuel flow now. Here from 0 to the left engine, going up 0.5. So we come here outside, you're gonna see the engine spinning more rapidly now. Here we have the engine start, this engine. Now it's fully working. So we're going to the other side engine now. You can see the right wing engine now is off. You can see the right wing engine is off. So this is the Boeing 777, so we need to start this engine now. Have about 30 minutes to go, so we're gonna start the right wing engine now. So you can see the items now. Reconfigure the N1 increase, the exhaust gas temperature, the N2, the fuel flow is 0, the oil pressure, fuel flow is 0 because this. You need to turn on the fuel flow, so you can see the compressor of the engine having high, the right wing engine having high N2, which makes the engine spinner rotate the front fan. So you can see the front fan of the turbojet engine. So we're gonna let this, we can let this right wing engine now having fuel flow. As you can see, the N1 is gonna increase rapidly also. So is the fuel flow now. It's going up. So we have the right wing engine now on start. So you can see here the spinner going higher and higher. The right wing engine. And here we are fully start. We can now complete the last part before takeoff. Just set up the flight management computer here. So we have this item, we have FMC flight management computer, the model here, the components we have G90. So the reference airport is this, Zurich International Lszh. Route from Lszh back to Lszh, copy paste. Runway 14. So we have 0 fuel weight, total weight with fuel added, gross weight 235,000. This is gonna be a takeoff weight. Flight altitude, our cost index for this flight 100% and 5% are reserved. So cruising temperature and cruising center of gravity 7.5%. have limit departure arrival here, departure from this runway 14, transmit to Alpha, this is departure and arrival, Lszh 14, you can see the route approaches here, we trans this, Negria 1 Alpha, trans so you can see the legs, we have this discontinuity, we cancel discontinuity, we press here activate and execute to have the full flight plan ready. So we only need to set the flaps here and the center of gravity, the stabilizer trim, that is gonna give us the takeoff speed for this runway and this takeoff weight. So our takeoff speed is 155 knots, we rotate 140, V1 133, so this is the ref speed plus 15 degrees center of gravity, 36% of the mean aerodynamic core. You can see the center of gravity position here, the trim of the horizontal tail of the aircraft. So we are full configured for takeoff. We're gonna use all these, the LNAV in the autopilot. So I believe we are now ready for takeoff. We have like 35 minutes left for this flight. So we're going back, disarm the parking brakes, advance the thrust levers, so we use the steerer to steer the nose wheel of the aircraft and the rudder pedals. So the runway is clear for takeoff. So we keep using the steerer. Have like 30 minutes left to go. Use the parking brakes one more time. See an outside view here where we are. We use some lights, landing lights here. So we have a nice view here outside for this takeoff. Here we are, we need like 30 more minutes. So you can see here is everything configured right, the primary flight display, the airspeed selected, the altitude selected, the barometric altitude of sea level, the ILS localizer with the crossbar, magnetic cruise heading, and here we can see the flight plan. When I use a little bit less of a range, you're gonna see a new view. You can see this line here with these waypoints. This is the flight plan, the position, the runway we are right now. So if I advance the thrust levers now forward. This is the autopilot panel also configured for takeoff. We have the N1 increase, the exhaust gas temperature, the N2 fuel flow, total fuel here, the flap settings, the land gears down, there's no warnings. The N2 93% fuel flow, 5,000 kilograms per engine per hour. So if I increase this, we're gonna have more of this thrust. So everything is normal here. We can disarm the parking brakes and go. Have like 20 minutes left for this flight. Here we go, you can see. Still have 70 knots, airspeed increasing, using full takeoff, go around power. You can see the airspeed here, 90, 130, you can see V1, we rotate. So we have V1, we rotate. And V2 is the takeoff speed. So here we go. We have positive rate here of climb. So we retract the landing gear here. So you can see as we climb out, we are just 700 feet above the ground level, 800, 900, 680. Our airspeed 270 knots, our altitude above the sea level 3000 feet, and our rate of climb 4000 feet per minute. You can see the ground here, the terrain scan. We have a nice view. We are 2000 feet above the ground level, 3800 above the sea level. So you can see the runway here, the flight plan we're going to be flying. So this is the takeoff configuration for this aircraft. I will fly manually. Keep climbing out. We use full takeoff ground power. So we have 36 minutes left for this flight. Actually, for the full flight, we want to use the full flight mode. Keep climbing here. We're gonna reach the next waypoint here. Over here, the route, right? We cross 7,000 feet. You can see we have the stall speed. We have the maximum airspeed for the flap series right now. Maybe this red. 8,000 feet. We climb. We have a maximum. We have an open glide right now, as they call in the Airbus. Maximum glide. So this is our aircraft. Just after departure. So this is our spacecraft now. You can see the star sign here. The Boeing 777-300. We have the galaxy view here, and galaxy view, and star sign. This is a beautiful aircraft. This airplane we fly right now. So I'm your pilot captain, Thomas Hatsios, flying the Boeing 777-300 ERX. Thank you for flying with us. Have a nicer view here. We'll keep climbing. We trans this waypoint. We're gonna cross it right now. So the legs are direct to have the next vehicle now. There we go. So we're flying direct into here. This waypoint, 16,000 feet. We have the LNAV, we have a flight path angle decrease. We use the flight level change here in the altitude for the other thrust. this airspeed. So you can see here we have the stall speed displayed with this yellow corner here. Let's see, we avoid this. We have the flap settings, the fly-by-wire system with blue, the rate of flight 2,450 per minute, feet per minute. So maybe use a bit more flap. So this is flying the Boeing 777. We have like we're gonna be overflying maybe a little bit Germany, so there is that. We have about 15 minutes left for this flight. So you can use manual input for the auto throttle. If we disconnect here the auto throttle switch, I'm gonna use the manual input. So you can select a higher rating to climb higher, faster. We also have this warning now for the stall speed. So our max speed is 0.457. You can see the modes here. Our max speed is 0.457. So it's about 600 kilometers an hour. We're flying 600 kilometers an hour, about 200 meters per second, over flying Switzerland. So you can see this results here. The St. Gallen Lake is going to be overflying. Okay, we have a nice view here. This is the galaxy here, the star sign. So this is our spacecraft for tonight, Boeing 777-300 LX. This aircraft. You can see 600 kilometers an hour right now. Our airspeed about 31,000 feet above the sea level, or about 6,300 meters. You can see in this way we have the Germany in front of us with the Bayern Munich and the Bavaria. If we keep flying forward, we have like we have 20 minutes left for this flight actually. We're gonna keep climbing a little bit further. Our max speed is 0.5, or about 650 kilometers an hour. Climbing a little bit higher, maybe retract some flaps. Now we don't need so many flaps, so this is going to increase our airspeed to a higher level. You can see the flap setting here, flap limit moving forward, so retract the flaps one more time. We're going to have higher airspeed margin. So you can see also the stall margin here. You can see this. We are just a few more feet away from our climb altitude here. This magenta symbol, so we can start going back into the airport in like 15 minutes from now. So here we are flying manually. This is Mach 0.555, 558, 516. The rate of flight 400 feet per minute. Flying manually. Here we are, 35,000. You can see the fly-by-wire FBW symbol. This is the auto trim system that so it balances the aircraft in flight. So we have Germany in front, the valley of Bayern and Munich, München. So it's like 8.5 miles in front of us. So you can see this beautiful view of the Germany now and Switzerland. So we have also the chemtrails here. This beautiful display of the vapors, the frozen vapors from the engine, you can see. So we need to go back. We are overflying German valleys now. We need to go back now. Grab the frozen vapors from the engine. We're flying with about 700 kilometers an hour at 36,000 feet. About 8,000 meters above the sea level right now. Flying with 700 kilometers an hour, 750, maybe 800. Quite fast. So we go back into the airport right now. We make a nice turn over flying Germany. Let's see. So here we have the chemtrails also in the contrails, the vapors from the engine. Flying with about 850 kilometers an hour, 8,000 meters above the sea level. So this is our spacecraft. We fly through the stratosphere right now, very close, above the troposphere of the Earth. So 37,000 feet. Maybe increase the airspeed now, or higher level. I will keep turning, fly direct into Lszh here. So we're gonna fly direct into, and we're gonna use the autopilot in a couple of minutes. We have like retract all the flaps here. We don't need so many flaps. We need like 15 minutes to go for this flight. So we go back to Switzerland now. We overflying the Switzerland. Here the Swiss Alps. As you can see, we can also connect the autopilot if we need. Use the flight level change here. So here we are at 35,000 feet, just 49 nautical miles away from the next waypoint. So we have the chemtrails now, very nice, from the engines, vapors, as you can see. This airplane is flying with 900 now, maybe 950 kilometers an hour, about 7,500 meters above the sea level. You can see the frozen vapors here we have in the engines. These are very long aircraft. These beautiful wings, the turbojet engine. So 950 kilometers an hour, about 300 meters a second. 7,500 meters above sea level. So we need to go back inside now. can start the approach process. We are just about nautical miles away. Have like 10 minutes left for this flight. So we're gonna start descent in a while. You see the airspeed mark 0.774. You have to select one more thing here for the approach. Later, I'm going to select this. So we are 33 nautical miles away. I'm going to set a lower altitude here, like 6,000 feet and lower airspeed. So we press the flight level change and select the vertical speed, flight path angle, what we like. We also use the speed brakes. Here you can see the auto throttle moving, the thrust levers down, backward, slow down the aircraft. You can see as we descend down to the Zurich and Switzerland. This is our descent path now and descent rate, 3,900 feet per minute. Airspeed about Mach 0.7 or 850 kilometers an hour, 33,000 feet. You can see the runway here. And the flight path, the autopilot is on. This one with the autopilot. You can see the autopilot here also. Autopilot is on. Have about 10 minutes left for this flight. About 36. We have 10 minutes left for this flight exactly. This is cool. So here we descend. You can see the star sign. Now we have a beautiful star sign here with the galaxy. So this one more time. Spacecraft for tonight, the Boeing 777. 300 ERX, the special view of the galaxy here, this beautiful star sign. Quite high, 18,000 feet. You can see the Switzerland now, as we descend. This flying with 750 kilometers an hour. So we're closer, 1.5, ready, not from our range. 1.4. Maybe we're gonna make a shortcut, I'm not sure. I believe we're gonna descend faster now. So we have the runway here. We're in a very nice position for making a shortcut. Okay. So we need also to slow down a little bit. We're going inside our engines right now. You can see the idle here. The N1 is idle. You can see the engine display, the N2 also idle. And the thrust levers position here idle. So we need to make one last selection here. The approach rest. This is gonna be our approach speed, 151 knots, flaps 35. We need this. We're at 12,000 feet. We are about to land in a couple of minutes maybe. So we have 8 minutes left to go. We're having plenty much time to approach the land. This is our speed. So we need to start slowing down, maybe extend the landing gear now. This is gonna slow us down. We have the we're also gonna disconnect the autopilot now and fly manually. So here we are as we descend, very closer to the ground. You can see the landing gear here extend. This is the river. I'm gonna start turning to the river now. Not least come like this. You can see our airspeed 250 knots. We have to slow down further. Disconnect the warning here. So here's the runway here. We need to fly over there. Flying manually now. Decrease the airspeed a little bit more. And also use flaps now. Extend some flaps. Now for landing, we're just 4,000 feet. Keep slowing down, and we slow down a little bit further. So we're overflying the river here. We need to slow down. Make some maneuvers to slow down. I forgot the Lszh localizer here. This mode. You can see outside here where we're going. So here we are. Into the runway position. Just for landing. Use manual and automatic auto thrust. Avoid the stall. So you can see we have the Lszh localizer here, the radio altitude above the ground level, the altitude above the sea level, the glide slope, the airspeed. We have the runway here, so we're gonna be aligned with the Lszh localizer in just a few seconds. The Lszh localizer and the vertical glide slope. The Lszh localizer is the horizontal localizer for this runway frequency. Τώρα φεύγω σε 5 λεπτά. Περίμενα. So here we are. Five more minutes left for this video. Keep flying. So here we are aligned with the Lszh localizer here. This needle you can see. Also the localizer. We are 1,000 feet above the ground, 170 knots. We need to use the sync rate now. Fully aligned with the runway. Very nice alignment. We're gonna make a nice landing. Very smooth. The Lszh localizer. So here we are. Approach speed 165 knots. 50, 20, 10. Here we are. Flare. Starting flare. And here we are just landed into the runway. Very beautiful landing. reverse thrust here, full reverse, brakes, full reverse, so we have full reverse here and parking brakes. Here we are into the runway for exit, so we just made a nice landing. You can see, you can turn on some lights so you can see better what we did outside. So you can see our aircraft is fully configured for takeoff, go round again. There is no fault message. This is the flight director. Made a nice landing. We have the thrust reverse here. So here we are, just landed, runway 14. We can exit the runway if we want. So you can see the nose wheel tire here is perfectly well. Nose wheel here. The tire in the strut. There is no damage to the nose wheel. All tire. So is the landing gear here, very safe. No problem with that. So we see the systems again inside. You can see the nose wheel here and the landing gear, no damage. There is no blown tire, no strut, so broken. You can see that we did a nice landing, very nice, very beautiful, very smooth. So this is the Boeing 777-300 ERX, nice flight. So that was your pilot, Captain Thomas Hatsios, flying the Boeing 777-300 ERX tonight flight. Thank you very much for joining me. I'll see you next time. Bye bye. Bye. Bye.